My name is Christopher Roche. I've been working in nuclear for a lot longer than I'd like to admit right now. The picture of me in the presentation is kind of an old one, but what we do, I want to talk a little bit about what we do as a company, how we're using VR, why it's really changing what we're doing, and how it's really improving and is going to improve, our production in the future and our performance as well. Not just do things faster, but do things better. So a little bit about what we do. We provide a wide range of services for nuclear power plants worldwide. I've worked in the United States, I've worked in Mexico, I've worked in Japan, I've worked in Taiwan. I've been to Europe, but I really haven't done a lot of nuclear power plant work there. So we'll do everything from disassemble a nuclear power plant after they shut it down. We'll fix it, we'll inspect it, we'll refuel it. And one of the things we want to talk about now is refueling. So when you shut down a nuclear power plant, if you think about it, it's not like the gas tank in a vehicle. You don't just fill it up and when it's empty, you're done. You have to shut it down. The fuel lasts for about 3 cycles. So if you think about it, we replace about a third of it, and then the other third we shuffle. And the newer fuel, and for lack of a better term, is a little bit hotter than the older fuel because the older fuel is partially burned up. So we do a shuffle, but we're moving around these fuel bundles to make sure we have nice, even power across the core. It's a little bit difficult. They're deadly radioactive. They do glow. That pretty blue glow you see down there is actually mostly lights. But when you do pull the fuel bundles out, there is a cobalt blue glow that's pretty impressive. But if you look at it, I don't know if you can see my cursor here, but there's a mast, and you have a person at the top of the mast. And what that's doing is it's reaching down about 80 feet into the water, and you're gripping one fuel bundle by the bail handle, lifting it up and moving it to where you need to move it to. There are 3 people involved in this process. There's the driver, which is the person here that you can see on the upper picture, that's actually handling the mast. You have a spotter who is coordinating the efforts and telling the driver where to maneuver the bridge that he's operating and what to do with the fuel bundle. And then you've got a senior reactor operator. And that senior reactor operator isn't one of our team. That's actually one of our customers who is a licensed, so basically they're government certified to be able to operate this reactor. They're there because if we put a fuel bundle in the wrong location, or we have an issue with the fuel bundle, we're dealing with reactivity here, and we don't want to make mistakes. So it's very, very critical. And to have these 3 people communicating efficiently, coordinating their efforts efficiently, is very, very important. And a lot of times when we start out an outage, there will be over 500 individual fuel moves in each outage, sometimes many, many more. But when they start out, they're still kind of forming themselves as a team, and they're not firing on all cylinders, as we say. So this is kind of what we're talking about as a company. When we do training, what we've done in the past is we build physical mock-ups, and we train our people on those physical mock-ups. So it's hands-on. So in San Jose, California, we have a full-size boiling water reactor mock-up, and we can take students out there and we can train them to move fuel. We can put them on a mast and they can move their dummy bundles, but they're still fuel bundles, and we can go do that. The problem with that is we have to fly everybody out there. We have one mock-up, and sometimes it's not used for moving fuel. Sometimes it's used for moving something else. So it's got limited availability. And you also have a limited, once again, I talked about we had customer people there. To get everybody together to coordinate that is very, very difficult. Those senior reactor operators are in high demand, and the sites do not like to let them go. And they don't like, especially for a week or something like that. They're very, very skilled, very, very skilled people. So we were looking at, hey, how can we improve our fuel moving capability, our fuel moving coordination? And this is for not just training new people, but also making sure that our experienced people are maintaining their proficiency. And we started looking at what kind of simulators can we build, what kind of simulators can we put together. And we were coming back with a lot of, that's really not going to work for us. We weren't getting any good solutions. We weren't getting anything that was going to work. We got introduced to Virtualware, and one of our executives in Europe, found the company and was impressed, and said, "Hey, look, let's give them a try." So we signed a contract to do a proof of concept with them to make a virtual reality fuel moving simulator, and that's what we're going to talk about today. So if you look at the, what we were able to do is actually incorporate physical controls that replicate what people do in the field. So this is an actual mast in a nuclear power plant, and this is the driver here. And this is our virtual mast that we have that replicates that. So it's the same kind of grid around there. So the person's going to see that, they're going to feel that. It's going to feel the same way. It's got haptic feedback. This is a telescoping mast, and it's a long telescoping mast. And when those sections hit each other, it rattles everything. This thing is great. I mean, it rattles things just like it does in the field. So it's very realistic in the way that goes. We have a permanent virtual reality room installed in Wilmington, North Carolina. That's our headquarters. We also have a mobile room that's designed to be sent somewhere, set up, and we can put it almost anywhere that we can get power to it and everything else. And what's nice is we can set that up at a customer location. The SRO can go into that room. We can have people in Wilmington, North Carolina, and we can network these two rooms and have two groups that are in different physical locations working together, communicating and operating in the same virtual environment. So we don't have to travel SROs. We don't have to travel our fuel moving team, to the site. We eliminate a lot of that cost, but we still have something that's very realistic, that's very immersive, and that really is focused on that communication, on the coordination, and reinforcing the process that we're trying to train. So this video I'm going to show was taken, and this doesn't look like what I showed you last time. This is one of the prototypes, but it gives you an idea of the user number one is the spotter. The user number two is the person on the controls there, and it gives you an idea of what they're doing in reality in the room, and then what they're seeing. And it starts off, and I'm just going to play this and kind of talk through it and give you an idea of how we do this. So basically, this is setting up. Everyone's getting in place. They're getting ready to go into the simulation. You see the person holding their hand up. Basically, that's the field movement form. That's the form that they use to say, hey, we're going to move this bundle to this location. Now they're in the simulation. So now if you see them when they look around, it looks like a nuclear power plant. It looks like an actual bridge. There's water. You can see ripples on the water. All of the indications that you'd have are present there. Camera views are present. What user one's doing right now is we call that circle slash. That's placekeeping. He's testing that. We have an IR sensor on the front of the goggles. So when they're looking at a core map, or when they're pointing at something, they can maintain focus like they would in real life, and they can count over spaces and do things like that. So we're kind of jumping around a little bit, but they're actually lowering the fuel bundle now onto the grapple. And you can see this is a much more rudimentary mast setup, but it was very useful in proving the concept and developing the final one. So you see in virtual reality, all the lights come on just like they would just like they would on the bridge. All of our interlocks are programmed into the logic. There's a lot of things. There's a lot of things we can do here. But I mean, when you look at the environment, it looks just like what we work in. Maybe a little bit cleaner. So they've got a bundle on the grapple now. They're moving it to the next location. So you see, I mean, we marks on the floor showing them where they are on the position, in the core. Looking down, so he's counting over. Hey, here, making sure they are where they say they are. Doing that verification. Then he's looking at the camera as well. And now they're inserting the bundle into the core. So this whole process, and what you can't hear now is their communication, but we've got a very, very formal process for doing this. We've got, it's a very large procedure. It's very scripted. The communications are very prescriptive. It's kind of, think of like an aircraft checklist. When you're doing that, these are the things we have to do every time. Here are the concurrent and the independent verifications that we perform, so we don't put something in the wrong orientation. We don't put something in the wrong position, and we don't have any of these errors that are going to, make our customers have to report to a regulator or something else. So when we were looking at this, what are the real benefits of training in virtual reality? Well, one, we can train in a realistic environment. Sights, sounds, and feels of the power plant are well modeled and they're immersive. It's amazing watching people when they go into the virtual environment, because in the virtual environment, if you're on this bridge, you can walk through the guardrail and you can walk into the water, but it's amazing people won't do it because it's that realistic. It's that impression. It gives you that impression. No, I don't want to do it, and they have to make a physical effort to actually go do that. And it's kind of neat when you do. But when you think about it, sight, sounds, and feel are the critical things here. Smell and taste, we're not that worried about in a nuclear power plant. But coordination and communications are just as they would be in the field. It's the same communications, it's the same indications, they're getting the same verifications. And this is really the critical aspect of the training we're doing. It's not so much the exact feel of landing on a fuel bundle and what it feels like to do this. That's pretty straightforward. That's not what we have to do. Where we make mistakes, and that's really the key thing here, is we looked at where we made mistakes and where we had issues, is coordination, communication, and following the process and doing those verifications. So this is an outstanding tool for that, and it works very, very well. We have lower cost and a higher availability. To train people out in San Jose, first I've got to buy them plane tickets, put them in hotels, get them rental cars, feed them, and all those kinds of things. In Wilmington, I can have this up and running in just a few minutes, and we can be training from turning on all the computers and getting everything set up to actually having people move fuel is probably about a half an hour. And we've got a lot more access to it. We can do a lot more training. We can, really work with a lot more students and teams in this environment than we can in San Jose. Just because San Jose, if we're using the mock-up to do some engineering work or something like that, it's not available for our use. I think the biggest thing we can do in VR that we can't do on a physical mock-up is train for abnormal situations. There are things that come up during field moves. We call them leaners. Let's say you set it and it hits something, and instead of going down in the slot where it's supposed to, it catches on something. Well, that fuel bundle is going to lean. We have to be able to catch that, stop what we're doing, and take the corrective actions immediately so that we don't cause something bad to happen. That's not something we can or are willing to train with on the physical mock-ups because we can actually damage the mock-up. However, in virtual reality, we can insert problems. We can make something happen. We can change a serial number on a bundle to see if, hey, are you doing your verifications accurately? Are you picking up the right bundle? Part of that is verifying that serial number. We can create those kind of anomalies in the simulation to let the people catch what's going on. In the built-in analytics, so once if we put a team in there and we run them through a thing, and let's say they do 10 fuel moves, once we close that session, it gives you all the analytics on what happened. Hey, when did they not follow the process? Because it tracks everything that we do automatically. What was your fuel move rate? Where did you have issues? What was going on? And that helps the instructor communicate with the students and give that feedback that's critical to making sure that we're having effective training, as well as going back and actually reviewing what the students and what the teams did. So what's next? For us, our fuel movement simulator was kind of our killer app. That was what got us into virtual reality. We saw the value immediately, and we started developing this. And I'll tell you, we actually got the final mast in late last week into Wilmington. The final mast design. The team put it together in the room. Within an hour, we had it up, we had it running, and we were moving fuel on it. And it was absolutely impressive. Yesterday morning, we did our first customer demonstration with the fuel moving mast, and they were blown up with the simulation. And we had people in there. We had seasoned fuel movers communicating, coordinating. We had what was going on up on the screen, and we had a whole panel of customers, and they were just blown away by how well it worked, how immersive it was, and how it focused on exactly where we've had issues, and they can see the value there. So the other thing they're looking for is fuel move rates. When we shut down a nuclear power plant, it costs a lot of money. When these teams start off, they typically aren't as efficient and fast as they are toward the end. So once again, another benefit of this is if we work with the teams and get them proficient, working together smoothly, coordinated, and then put them in there, we may be able to cut down some of the time for this refueling outage as well, while maintaining quality and actually improving quality, because a lot of the fuel movement errors we have are at the beginning when the teams are getting used to working with each other. So some things that we're working on in the future: dynamic supervisor training. Supervisor training is one of those things that's very, very difficult to do. You can talk about it, you can set up static environments to go look at, but you really can't put someone in a dynamic environment and have consequences if they don't take the right actions. And this is an environment where you can. And those consequences can be very, very impactful. If you're watching a team that's doing a rigging evolution, for instance, and they do something wrong and the supervisor doesn't catch it, you can have something fall. You can have a load drop or something like that. In virtual reality, we can model that, make that happen. In real life, we don't do that. And believe me, it's impactful in virtual reality, and it's going to have a lot more. You're going to have a lot better retention, and you're going to have a lot better internalization with someone when they do that. Familiarization training. One of the things we do at our mock-up in San Jose is we can actually drain that down, and we put people in a man basket and drop them down into the vessel and look at the components that are down there so they can see, hey, this is what it looks like in real life. And what people usually do is they remember the man basket ride because they either loved it and they thought it was fun, or they were scared to death and they didn't want to do it. But all the rest of it, they never talk about. What we can do with virtual reality is we can take our inventor models, we can take all of our reactor models, put them in virtual reality and put someone virtually in there, they're looking at the same type of thing, except we can show them a much broader range of components. We can show a much broader range of areas, and we can, facilitate that familiarization training more completely and less expensively. And the other thing that we're really focused on right now is supporting new designs. We want to let design engineers see what they're developing almost in real life, in real size as they're doing it. We also want the people who are experts in servicing to be able to go in with the design engineers and say, hey, look, you put this here. When we do this, we've got to bring things in this way. It's not going to work. Here's how we're going to have to organize the refuel floor. Here's how we're going to have to do this. And we're going to see, wonderful benefits in our design for maintenance. And that's something that we've always kind of had to overcome, building physical models and doing things like that. I think we'll really be able to get in there, drive the proper dialogue between the people that design and the people who service. And really that initial design is going to be much, much better than it was. And it also gives people an opportunity to see what they're working on. That's basically what I have, David. Are there any questions that have come up, or would you like to wait until we switch off?
Well, I guess we have many questions, and as we have time, I will drop you at least 3 in 1 question, okay? And maybe you need a panel, then we have more time. If not, I will send it to you, and maybe we can answer them, and give them to the audience, next week, maybe with the recording. So 1 in 3 is, this setup is a single installation on one side. What's the process for installing the VR simulator? Do you have to train the tech to set up, or this has not been moved to a production level? It's still maybe in pilot. Thank you, Mark, for this question. So, Christopher?
No, actually, it's a great question. So we have one installation right now that's set up, but we also have all the equipment for the mobile room. So basically what we'll do is we'll move the mobile room and all this equipment to the installation. It takes about 12 hours for about 3 people to set up the room, set everything up, and then they're ready to go. A lot of our power plants are centrally located. In Illinois, for example, we've got 3 power plants that are very, very close. If we set it up in a central location, we could have people from all those 3 power plants come in and train at once. So we have, it's a great question. Right now we have one simulator set up. We've got another mobile simulator that's able to be installed remotely, and we're working on ordering a third.
So right now,
does that answer the question?
Yeah, I guess so. One of the questions is, okay, are you still in pilot, moving to the production line? And what you're doing now, it's like moving to the production line. I mean, you're, starting with this, you have that filming simulator, you start to, bring virtual reality training at scale. And this is, as you mentioned before, this was the killer app to do so.
Right, and like I said, so this was what got us into it. So now we're bringing virtual reality into, and we're exploring every other place we can use it. There are some things like say a hands-on like torque training, where we're training people to torque a flange and using torque wrenches, where virtual reality is not the best method. However, we're looking at augmented reality to do some of that work, and we're looking at augmented reality to do some refurbishment work where we can minimize the potential for mistakes by superimposing procedures or part diagrams or something like that while the people are doing the work and doing that. So yeah, like I said, that's part of this what's next slide, is dynamic supervisor training, and we're developing content as we go. Like I said, we just got the field movement simulator done, and unfortunately, we've actually driven quite a bit of investment with our company based on this field movement simulator. And now that we have it and we can show our leaders and everything else just the value of it, we're going to drive even more investment. And I see us spending a lot of time. I see us gaining a lot of advantage, and getting a lot better because of this.
And it's amazing. You are joining for sure. This VR is now movement. The last question regarding of sickness, and how long does a trainee be in the MERS, environment? Because here, maybe in the past, there were like, issues when you spend, a long time in immersive environment. But I know, as we were part of that test that we've seen in the video, the field, service team spent, a great amount of time without any kind of sickness, being trained.
I tell you what, it's a great question in the environment that we have, because it tracks where you are. What we found is that very, very few people are sensitive to it, because when you move in real space, you move in virtual space the same way. So you don't get that that disorientation between your inner ear and what you're seeing, which causes that motion sickness. We've had a couple people who are sensitive, and that's something we have to work with. But most people can be in the environment for well over an hour and not suffer any ill effects. They can pop in and out, and it's been very, very stable as far as that goes. One of the things that we do have is we have people in there acting as spotters, so no one runs into a wall, because virtual space is a lot bigger than actual space. So there are safety things that you have to go through. There are some things that you have to manage. And people get so immersed in it that they'll walk right into a wall because they don't see that wall in virtual reality. So, but yeah, really, as far as people being comfortable in there, it's actually very, very comfortable. I've been in simulations where games and things like that, where it really upset my equilibrium. This doesn't bother me at all. And it's amazing how much this technology has gone from a technological, interesting thing to actually a tool that we're using, and we're gaining advantage as well as improvements from. So.
Well, thank you, Christopher. And actually, that gives me the opportunity to answer one of the test questions about these Unity-based applications, a Unity-based solution, okay, that's simulated. And another thing, as you mentioned right now, it's about why you haven't used, let's say, Quest or Quest 2, and it's because that tracking part, because you need an absolute tracking so you can reduce even this kind of sickness that you can get, with, that disorientation, mainly with the tracking system. So thank you, Christopher. Thanks for your time. This is amazing. We have more questions. Let's see if we have time in the live Q&A panel, but at least we have time to answer some of them. So thank you, Christopher. Thanks for your time.